Hi, I'm Mike. For my sins until, well, a couple of weeks time, I actually work for Amazon or for LoveFilm, but since we're shutting LoveFilm down, I'm out of a job. But this is a little bit of something that cropped up while we were building various bits and bobs to do with handling sessions for Dancer, which is kind of fun. So sessions. If you're not familiar with the concept, here is your typical HTTP request-response request. The point being that HTTP is stateless, so at least in theory, unless you do clever stuff, what happens in this request-response bears no relation to the next request that comes down the pipeline. But the conventional way around this is you set a cookie when you first see someone with a session ID. And then when they come again, they pass you that session ID, and you can store data associated with that ID in order to persist information between HTTP requests. Session storage then basically becomes a matter of some kind of key value storage. So here we've got a bunch of session IDs basically for various people. Obviously I come in with the cookie and we find the right session and we pick out my data. All right, who spots the security flaw there? Sorry? Yeah, one of the major points is your session ID generation here is entirely predictable. If I was to delete my session cookie and come in again, I'd probably notice the next session I got was 21336 and think, oh, that looks little, and go and try various others, and suddenly I've got Larry Wall's permissions or MST's permissions, which is not really what you want. So, first takeaway is, obviously you don't use monotonically increasing session IDs, you use random. Next one, where do you put your sessions? The obvious thought might be in memory. Now this works brilliantly for the Dancer development thing, which is a single-threaded, single HTTP, but as soon as you get a multi-process thing, your sessions are not shared between processes. Now obviously you can do some fancy shared memory stuff, but that starts getting complicated, so store them on disk. Simple. Be old school, use TIE. There are YAML things that write to file. The only problem with this is as soon as you disappear behind a load balancer, which is getting more and more common these days, those two aren't the same file. Now obviously you can get around that with shared file systems, stick them all on S3 or something, but yeah, the obvious solution is of course stick it in a database of some sort. In fact, you really only need a key value store for this kind of thing. So what have we got available to us? Within Dancer's core there is Simple, which is one of the aforementioned in-memory sessions. It's the one you use when you're whipping up a little Dancer application to play with, and you know you're only using the single-threaded dev server. There's YAML, which uses YAML writing to file as a concept. Again, only useful on a single server. As soon as you move to behind a load balancer, you're going to start wanting cleverer things. And then sitting around on CPAN, we've got DBIC, which obviously enough uses a database. We've got Redis, which uses the Redis KV store. We've got MongoDB, if you're mad enough to want to use MongoDB. We've got memcached. We've got Cookie, which is kind of fun in that it sticks all your session data in the cookie in a quite secure, encrypted manner. The only problem with that is on a Mac, that will screw you because there's a maximum size to your cookie. So if you get overzealous about what you stick in your session, you're stuffed. So, we're going to use DynamoDB. I don't get a choice. This is Amazon when I was working for them, so I get to eat our own dog food and use our own KV store. So, dive into the AWS console. We create a sessions table with a primary key, which is the ID. That should actually be number, not string. Dancer generates session IDs for you, and they're actually numbers. You don't need to do anything else because of the way DynamoDB works. It will create attributes, so eventually we'll start feeding stuff in here under the attribute data, and that will just magically leap into existence as you start. So let's write a session handler. There's some very nice documentation in the Dancer cookbook on how to do this, but essentially you write yourself a subclass of Dancer, something in the Dancer2 session hierarchy. In this case, Dancer2 session DynamoDB. We're using Moo. If you're not familiar with Moo, Smaller, cuter, cuddlier, slightly less stressful version of Moose. Basically, it's Perl OO done cleanly and readably. And we also say with Dancer2 core role session factory. And what this does, this is the clever bit, what this does is it provides us with a bunch of methods that are imported into our class plus some requirements. Now, roles, if you're not familiar with roles, it's like multiple inheritance, but quote, much more clever and meaningful. Essentially, it imports the methods that you define into the role into your consuming class. So there'll be a bunch of methods defined in Dancer2 core role session factory, which will get imported into this class that we're in the process of writing. And the other thing you can do is there is a requires directive which says that the consuming class must write these methods. Now, what this does is it hides most of the magic of sessions from us. So within Dancer expects its sessions to respond to this API. And all these are implemented in Session Factory and therefore in any class that consumes that role. But it also, if you look in the source to Session Factory, you will see there are these things marked as requires, which means we have to implement them. So retrieve, obviously, fetch a key from the store, change ID, destroy, flush, which writes it back, and sessions, which returns a list of session IDs. So let's carry on writing a new one. We're going to need some form of serialization. Obviously, because we're effectively a key value store, whatever structure we want to put into our session, we're going to have to turn into something that will just write as text into our database. And then we're going to pick a DynamoDB module. Don't use this one. Cool. Don't use this one. I didn't have a choice because it's the only one that's built into the Amazon internal code management system. All right. There, right. I would recommend using Pause, which is the Perl AWS API and supports all the different AWS bits and bobs. But as I said, I didn't have a choice. It does come up with a couple of salutary lessons. So for that, we're going to need to build a client for DynamoDB. Now, if you're not familiar with Moose and its relatives, has basically defines an attribute on the class, which we say is read-only, is an instance of Amazon DynamoDB. Lazy says we don't bother creating it until we need it, which just saves us a bit of work. And when we do, we call the builder routine, which creates us an object of this type. Dink. Onward. So here's build DDB client. Pull off $self. We call Amazon DynamoDB new. Obviously, we're going to need to be able to talk to DynamoDB, so we will need to find an AWS access key and a secret key and the AWS host, which for now we'll assume is stored on our objects, the object that we're in the process of creating somewhere. We also need to define the DynamoDB tables we're using. I'll come on to that in a second. And then there's a few odd parameters that we might want to use. Do we want to raise an error if things fail? And how many retries? AWS is somewhat notorious for occasionally returning 500 errors when the web service behind AWS is a bit notorious for returning 500 errors when things don't quite go how you expect. So it's well worth putting that 3 or 4 just to give it a chance to retry. It's more of a problem with things like SQS, but DynamoDB does do it occasionally. Now, so we'll define those attributes we just mentioned on the class. So has server, has access key, has tables. Now tables is something you pass to the AWS DynamoDB client to tell it what its table structure looks like. And in this case, you remember what we created back on the the DynamoDB console. Our hash key is ID. We have an attribute called data. ID is n, says it's numeric. S is a string. And that's our tables hash. Now, obviously at that point, we can set it on our object doing that, but there's a far nicer way of doing this. Because this is in the Dancer2 session hierarchy, then the Dancer config allows us to pass in any constructor arguments we want underneath engine session and the name of our session class. So in this case, our tables structure as YAML looks like that, which just maps into the hash I had earlier, thereby saving us having to create it, leave it in source code. We can stick it in the config file, and we can also do this. Another big security red flag: don't check that into Git unless you work for Uber. Please do not put credentials in config files and then check them into source code management systems that anybody else might see. Otherwise you'll end up in the newspapers. So one of the ways around that is looking at this. So we could define access key with a builder like we did for the DynamoDB object, and then we could have some form of credential store that we could go away and ask for the key, and then you don't care at all that it's not enshrined in your config file. You're talking to a secure credential store, which AWS will provide you one of. You can roll your own. And again, that gets you out of the nasty problem of leaving your keys lying around where other people can read them. Don't do it, please. All right, which then just leaves us with 5 methods to write. Destroy, which given a key destroys it. All very simple. You call delete item on our DDB client that we've created. You pass it the table you want to act on, and the ID you want to delete, and that's it. That's all you need to do there. Flush is the reverse, as you'd expect. We need to serialize because we're storing in a single field, so we'll turn this into from our Perl structure into JSON. Other serializers are available. Some of the session handlers use storable, which has the interesting feature that you can, if you're careful, you can actually store blessed objects in there and they'll come out properly blessed and behaving like objects. Unfortunately, not all Dancer and Dancer2 sessions do that. So if you write code that assumes on it and then change your session handler, you may fall over some awkward problems where your objects suddenly are no longer blessed, they're just hash refs. So again, consider carefully what your session hash is, what your session module is using for serialization, just in case you change your mind later. Okay, so having serialized it, all we do is we call put item, which does the reverse of delete item, given an ID and a data attribute. It shoves it in DynamoDB. Now DynamoDB supports put item and update item. The difference is that put item writes the whole object and replaces it. Update item, if I were to if I had multiple attributes on this, it would only update the ones that I actually passed in here, which is why we're using put, because sessions are big monolithic chunks and we don't try and do fine manipulation on them. So that's flush, so we can delete sessions, we can write sessions. Getting them back is almost as easy. In fact, it is as easy really. We call get item on the sessions table with the ID, and back comes a hash ref of attributes for which we want the data attribute, and then we just decode it from the JSON, and that will get us the Perl data structure that we wrote in the session in the first place. That's that. Sessions. This one comes with a bit of a gotcha. DynamoDB is not what's the word I'm looking for? It's not your ordinary friendly database. It really is a key value store. The equivalent of doing keys on it is both a little expensive and slightly fraught with danger. In that there's a function scan items, and it does a scan on the whole table and returns the items that match your search criteria. In this case, our search criteria for the sessions table is everything, so we don't pass any. But the other thing it does is, by default, it only returns a limited number of items. We want them all here, so this is actually one of the places where NetAmazon DynamoDB actually helps us, because you can pass it some extra parameters, and in this case we pass it all arrow 1, which says if you make the request of DynamoDB and it comes back and says here's some but that's not all, it goes around and tries again and fetches the next lot. And we say we only want the ID attribute because we're only fetching session IDs. And that will return us an array ref of hashes eventually, after potentially, if you've got a larger number of sessions in our table, that could take a while. That could take several iterations around the underlying AWS call. And then we just take the keys of the items. Yes, my apologies, it doesn't return an array ref, it returns a hash ref keyed by ID. So in fact, we'll just have a bunch of very minimal hash refs in here, and we just take the keys of it, and that will return us our list of session IDs. Yeah, sorry, I can't stand still. You need a wide angle lens. Ask away.
What does Dancer actually use that for?
I don't know. There are a number of session classes which cheat and lie and actually return an empty hash, empty array ref, but it is specified in the interface, so we will implement it. I've not seen any valid use for it yet, but it does exist as part of the API, so you should implement it. And then change ID, which is again not something you're going to want to do very often. This is a case where steal from the best, because everybody just about does this the same way. Namely, they fetch the old one, write it as the new one, and delete the old one. Okay, now there is the obvious observation here that you're doing an unserialized step, and here you're doing a reserialized step. So you may potentially not want to do that. You may, if you were feeling suitably efficiency inclined, you might want to unroll this bit of code so you don't have to have the serialization and deserialization step. But an awful lot of things, the memcached handler does that. I think the redis handler does that. Essentially, it's quick, it's lazy, it uses methods you've already written. We all believe in code reuse. And that's it. At that point, you have a Dancer session class using a new backend. If, without loss of generality, you can replace those last 5 slides with your own choice of backend, be it, I don't know, whatever other key value stores haven't got Dancer backends written for them yet, of which I'm sure there are plenty. Other than that, I think all I have left to say is a few things. Thank you very much to our sponsors. As you may have noted from the preamble to this talk, I'm looking for a job. Talk to these nice people who have my CV. And any questions? Come on, it wasn't that bad. Okay, thank you very much.